we are looking at the topic evaluating GenAI models, more from English and other languages. One of the key things now that we're seeing is there are a lot of models, a lot of GenAI models, LLMs out there, and which model performs better, or how do you really evaluate what is better versus the other? What are the frameworks, benchmarks? Specifically, so if we look at more of Indic and other languages, how do we see this evaluation frameworks? Why should we even evaluate? What's the need, and where is the industry or research going towards? So this will be our overall coverage. We'll start with address by Dr. Sunayana. She's going to talk about how they're spending time building these evaluation frameworks and models, specifically with languages focus in Microsoft research, and also what they've done in the Pariksha example. Once she takes us through her thoughts, we are then going to have a conversation. The three of us will delve deep into the industry application of these frameworks, evaluation models, and usage itself. And any other questions we'll throw open to all of you. So we'll start with Dr. Sunayanana's talk, and we welcome her. Thank you.
Thanks very much, Rupa, and thank you so much to Tai for inviting me to talk over here. So I'm really excited to speak to you about some of the experience that we've had over the last few years trying to evaluate AI systems and LLMs over the last few years, and also trying to tell you about what I see as sort of the future of evaluation, or what the hard challenges are that still remain. And of course, this is based on some of the experiences we've had, and so it's not that everybody has the same opinion, so these opinions are my own. But I do think that some of the things around benchmarking, et cetera, are getting more and more clear, given some of the new research that has come out. So I'm going to talk, as I said, about our journey so far, and this has been a few years of work with the rest of the team at Microsoft Research India, and also collaborators from academia and other parts of Microsoft. And some of the real challenges and opportunities we have, especially when it comes to evaluating in a multilingual, multicultural setting. Right? And that is of a lot of interest, I'm sure, to many of you who are looking at integrating some of these LLMs, SLMs, multimodal LMs, et cetera, into your own applications, into real use cases. Right? So let's get started. So what do we mean when we talk about evaluation, right? And what is the meaning of actually evaluating a model? There are many, many characteristics that we want these models to possess, right? Whether they are LLMs or vision LMs or so on. One is, of course, the output quality. So that is how well, for example, if it is a language model and it is trying to output something in a particular language, what the quality of that output looks like, right? That's one thing. Another dimension that's of critical importance is that the linguistic acceptability to a native speaker is good enough. And this is especially important when you're looking at things like dialects and variants of languages, et cetera. When you're looking at real-world tasks, right, you also want to make sure that the LM is actually doing the right thing in the task, right? So it's actually solving the task that you wanted it to. And in case there is some factual knowledge or something like that, or in a RAG setting, you want to make sure that it is not hallucinating, that it is actually grounded to whatever data that it is being supplied with. Another critical aspect of evaluation is safety. And there was a nice booth outside by one of the companies that's doing a safety leaderboard. And so by safety here, we mean things like it should not output toxic content, it should not be biased, et cetera. But also things like privacy, security, it should not be leaking sensitive information, et cetera, right? So when we're evaluating, we need to take that also into account. Calibration is basically how confident the model is. So we found actually that models are miscalibrated when they are in low data settings. So for example, for low resource languages, they very confidently give an answer which is incorrect, right? So calibration is off. And also many other factors, such as cost, for example, right? How much does it cost? How many calls are you making to LLMs if you have complex multi-agent systems, et cetera, right? So all of these things are really crucial to evaluate before we can decide whether we want to pick one LLM over the other. And you may have seen that there are multiple LLMs coming out, and here I'm going to use LLMs interchangeably with SLMs, VLMs. So I mean, all these language models. There are multiple ones coming out every week, right? And so it can be quite overwhelming to actually take stock of these and then decide which one to use for your application, or even if you're building your own, right? Whether it is better than all the others that exist, right? So there are several techniques that are used to do this evaluation, and I'm going to try and give you a big picture of some of the most popular ones today that are used for LLMs, and also try and give you some of the pros and cons of these techniques, right? So the gold standard of doing evaluation is human evaluation, right? You ask people whether they are okay with the output or not, and the gold standard is the users, right? So if there's an actual user of an application, then nothing like it, right? You can get feedback directly from the users about whether the system is doing the right thing in the application or not. Of course, this is very hard. You have to have users, first of all, so, and then you may not get a lot of signals. But then this is used quite a lot in some of the systems today. So for example, in the co-pilots that Microsoft has, we have things like thumbs up, thumbs down, and users can say whether they were dissatisfied with the response. If anything was unsafe, they can mark it, et cetera, right? So we get some signals from real users of these LLM-based application. Another kind of human evaluation is that you don't do it with a real user, but you still do it with a human, right? So you show the input and the output of a system to a human, and then you ask them to rate it on certain dimensions that you have specified. So this is usually done in the crowdsourcing kind of setting, where you may want to give a bunch of different people, maybe native speakers of different languages. You want to give them inputs and outputs from these systems and then get them rated or ranked, right? And this is, again, a good proxy, but it's not a user who's actually performing a particular task, right? So it's somebody who's performing the task of evaluation and not actually the end task. So it may not be as effective as the human feedback from real users, but it's still quite good, and you can do it at a larger scale if you're doing crowdsourcing and so on. The other way to do evaluation, and this has become the de facto standard now for doing evaluation of these LLMs, is benchmarking. So benchmarking is basically when you have these already available data sets. Some of them may be open source data sets, some of them may be proprietary. And what you're doing is you're running your model on all of these data sets, and then there is some metric associated with the data set, which is getting calculated automatically. And then that allows you to compare the performance of your model with all the other models that ran on that same benchmark, right? And so you can get a real sort of replicable evaluation here, and it makes it really easy to create leaderboards, et cetera. So most of the leaderboards that we see today are based on benchmarking. And this is also sort of cheap because you don't have to pay humans. Creating the benchmark is an expensive, laborious effort, but that's a one-time effort. And so you can keep using the benchmark over and over again, or so we think, right? And a lot of examples of these benchmarks you may already be aware of, like Glue and Superglue came a few years ago, which were trying to test like the general language understanding of these LLMs. There's also the Gaia benchmark, where it's doing multi-agent, agentic kind of evaluation. And then there's HellaSwag, MMLU, et cetera, which have become really popular recently for testing things like reasoning capabilities in these models. And then finally, there's this other interesting new technique that has come up, which is LLM-based evaluation. So here, the large language model itself, usually one of the really large ones like GPT-4 or Gemini or one of those, that is given the task of being an evaluator. So that itself becomes a judge. So it is shown basically the input and output again, just like you would show to a human, and it is asked to do the task of evaluation, whether this was correct or not, right? And initially, people started with things like BERT score, GPT score, where you show the correct answer, and then you ask it whether the answer that the LM produced is close to the, or matches the correct answer or not. That is what GPT score, BERT score do. But these days, we also have reference-free metrics, where the correct answer is not provided to the system, and it has to use its own knowledge to figure out whether the output that it saw was good enough or not, based on some rubrics and things like that that you define. So these are all the, of course there are more evaluation techniques than these, but these are sort of the basic evaluation techniques that we use. And there are pros and cons of all of these techniques, as you can imagine, right? Some of them cannot scale very well, some of them are expensive and slow, some of them are really fast and replicable, but there may be other issues with them, which we will go into later. So I'm going to talk about some of the work that we've been doing in the evaluation space, and our lab has been doing a lot of work on multilingual large language models and AI for a very long time now. And a few years ago, we asked this question about, in the previous generation of language models, so BERT and so on, how well are these models actually serving the 6,000 plus languages of the world, right? And the way that we answered this question basically was to try and estimate how much data exists in these 6,000 languages, and what is the kind of data that is used for building the models of that time, right? So the BERT model and so on. And then we try to estimate whether there is enough coverage or not of these data set of these languages in these particular models. So this is quite a celebrated paper from our lab, which talks about how we are doing. And I mean, no prizes for guessing that many of the world's languages with millions and millions of speakers, unfortunately, were not served by the BERT-like models because there wasn't enough data for them. Now, what about LLMs, right? So once we have these LLMs, there's a paradigm shift in how we train them when we compare them to the previous generation of models, right? And so how can we estimate how well these LLMs are going to do on the languages of the world? That was our problem statement. And I'm going to go back to the techniques that we have, right, at hand in order to do this evaluation, right? These 4 techniques. And what our lab did was basically, we actually did research in all 4 techniques, thanks to the partnership that we have with the M365 Copilot. So these are Office Copilots, LLM-based features that are available in Word, PowerPoint, etc. Thanks to that, we have real users who are using these systems in the enterprise for 25 languages. So we can get real feedback from users about how well these systems are doing for the 25 languages, right? So this is real feedback from actual users of applications. We also have a lot of evaluation that we do by native speakers. So we have crowdsourcing-like setups in order to do the second kind of evaluation. Benchmarking, over the last 1.5 years, we've done extensive benchmarking for multilingual scenarios, which we call MEGAVERSE. I'll go a little more into that later. And we've also done the first multilingual evaluation in LLM-based evaluators. So, in our view, this is the most comprehensive benchmarking that evaluation that we've done for LLMs in non-English languages, because we've done it in all these different aspects. So I'm going to go into the mega benchmarking effort first. I won't spend a lot of time on the results themselves, but this is more to give you an idea of why we did the benchmarking the way we did it, and also, what are the general problems that we have with benchmarking today. Okay? So this is more about telling you about the experience we have by doing the process of evaluation than the actual results that we get from the evaluation, although I will flash some of those also. So when we started with the mega work, which is trying to benchmark these models for multilingual languages, so basically, we can't do 6,000 languages because those 6,000 languages don't even exist in these models. These models typically have around 100 languages or so in them, because that's the data that you get on the web. So what we did was we selected multiple data sets that had reasonable linguistic coverage, and we decided to benchmark a whole lot of models on all of these different data sets so that we can create multilingual leaderboards, right? And so if you look at the language coverage that we had, we did have predominantly Indo-European languages, so the languages of India, Europe, etc. But also we tried our best to include some other languages like African languages as well, because we really want to know, right, whether these LLMs will work for those languages or not. And so the goal of the mega effort, the very first effort that we did, was simply to test the GPT models. At that time, GPT-4 had not yet come out. It just came out when we finished this effort. And we wanted to test on these standard benchmarks and also make sure that we have as many languages as possible covered so that we can get an idea of how well these models do, right? And for prompting, so how do you do this benchmarking? You basically take the task that you're doing for the benchmark. Say you're doing sentiment analysis, right? So you want to predict for a given sentence in Hindi, right? You want to predict whether it is a negative sentiment or a positive sentiment or neutral, right? How do you get the LLM to do this task? You basically construct a prompt explaining what the task is, right? So you tell it, you are somebody who's doing sentiment analysis. Sentiment analysis tries to figure out whether the sentence is positive, negative, or neutral. Now look at this sentence, and you take that from the actual benchmark, and then now tell me whether this is a positive or a negative sentiment, and then give me the answer in one word. That is how you usually prompt these systems. And then they will do the task, they will give you that one-word answer. You can compare it to the ground truth that is there in the benchmark, and you get a score, right? So that is how you do prompting, and then we did a lot of experimentation, and again, we did this in the initial days, even before GPT-4 came out, and so we did extensive experimentation on how you should actually prompt these systems in the multilingual setting. And the models that, as I mentioned, we did the GPT models, but we also compared them with the previous generation of language models, like multilingual BERT, XLM, Roberta, etc. And as I already mentioned, we tried to have reasonable language coverage, so we actually managed to cover around 70 languages with the first version of Mega. So it's not 6,000 languages, but it's most of the languages that are there in the 100-ish languages that are usually present in these language models. So what did we find? So we actually found in the days before GPT-4 and also when GPT-4 just came out, that there was actually a gap between the GPTs and the older models. And the gap doesn't mean that GPTs were better. Actually, the older models were better at multilingual than GPT. And this was actually one of the only things at that time that GPT did not do well, and even GPT-4 did not do well on multilingual. And even today, actually, this is still a challenge, even though we have GPT-4o that has come out, right, that has better tokenizers, et cetera, it does a better job. This is still a challenge for a huge model like GPT. It still doesn't do that well on multilingual, right, although its capabilities in English are phenomenal. So that's what we found, that for some languages, actually, there is a big gap between the GPT models, even GPT-4, and the older models. Some other languages, not so big, right? And which are the languages which GPT is not doing well on? They are the languages that are, of course, the ones that have less data, but also the ones that are written in scripts that are not the Latin scripts, right? And this, we found, actually, is because of the tokenizer. So our work was the first one at that time to point out that it's because of the inefficiency of the tokenizer that that is correlated with the lack of performance on non-Latin scripts. This was early last year. So general trends were that these LLMs are GPT-like LLMs are sometimes worse than the older SOTA models. We also found that within these models, we also compared to other models like Bloomsy, et cetera. We found that the GPT models were better. Once GPT-4 came out and we did all these experiments on that, we found that actually GPT-4 is much better than 3.5 and 3. And actually now it has improved even further. So when we run the tests now, we find that the gap between GPT-4 and the older generation of models has gone down or completely become nothing, or sometimes it has even overtaken the older model. So it's getting better and better. And generally, we find that the best performance is on the languages of the Germanic Romance family. So these are like Italian, German, French, Spanish, etc. And even the high resource languages, right? So these are languages which have lots of data, like Chinese and Japanese, Arabic also. Those don't perform that well. Whereas in the previous generation of models, right, those languages performed very well. Now, because of the tokenizer and other issues, because these languages are not written in the Latin script, they don't perform as well as expected, right? So we extended the mega work, we call it MEGAVERSE, and here the idea is not just to test GPT, but also to test other models. And so we wanted to benchmark models like Gemini, Gemma, Mistral, Llama, etc., all of those also, because by the time we finished this work, this was middle of last year, a whole lot of models had come out, right? So we wanted to see for all these different models, do the trends remain the same? Like, is it true that, again, there is not so good performance on certain languages? Is the gap still the same, etc.? Right, so there are more models that we've added, actually. This is a slightly old slide. So we also added the Gemini models, Gemma models. We haven't done Llama 3 in MEGAVERSE yet, but we did GPT-V and some other multimodal models as well. Data sets, we kept the same as Mega and expanded a little more, so we had 22 data sets. Now our language coverage went up a little bit. And the results that we saw were very interesting. So we found that these huge models, right, like GPT-4 and Gemini and Palm 2 also, those were much better than the SLMs on multilingual, right? And so they were much better than Llama and Mistral and so on multilingual. Although Mistral is good on 3 or 4 European languages because it is trained on those specifically. Overall, in general, it's not as good a multilingual model as, say, GPT-4, okay? We also found that there was a small difference between GPT-4 and Palm 2 at that time, but GPT-4 and Gemini in our latest experiments are almost equivalent. And we found similar trends on languages and scripts as we found in Mega. So across all these models, the trends were the same, that the Latin script languages did better, the non-Latin script languages, even if they were high resource, they did worse. And I won't go into this graph, but this is basically showing the same thing, that there are some languages for which the gap is higher, and the gap between the large models and the SLMs is really, really huge. So if you just look at the orange dotted bar, right, that is Mistral. And in most of the languages, it is very bad, right? So we see that for benchmarking, we see these clear trends. And that's the advantage of doing benchmarking, but there are a lot of different challenges, right? So one of the things that has become a popular saying is, it's attributed to somebody called Goodhart, is that when a measure becomes a target, it stops being a good measure, right? So the entire field tends to over-optimize on these few benchmarks. Like everybody tests on MMLU, or everybody tests on, at that time it used to be a data set called XNLI, right? So everyone starts doing whatever it takes to get a better number on that benchmark, and it doesn't mean that it is generalizable, right? But what's worse actually with this benchmarking today is that we found in our latest experiments that most of the open source benchmarks that exist today have already been seen by the large models, right? They're already present, the test data is already present in the training data, either the pre-training data or the fine-tuning data of the largest models, and also some of the small models. And just because a model is open source doesn't mean that we know what data it was pre-trained on, right? And so there's actually no way of guaranteeing that unless somebody discloses all the data that the model was ever trained on, including during fine-tuning and so on, there's no way of knowing whether one of these openly available public data sets has already been seen by the model or not. So there are several ways of trying to estimate whether something has been contaminated or not. This phenomenon is called data contamination. However, none of them are really foolproof. The other problem with benchmarking, especially in the multilingual setting, is that a lot of the multilingual data sets that are available today, they're simply translated from English, either automatically translated or translated by humans, right? And if you're trying to measure things like culture, linguistic nuances of different languages, et cetera, a translated data set is not going to cut it, right? Those things are going to get lost in translation. Also, some of the translation systems that themselves, if this is being done automatically, those may be poor as well, especially for the lower resource languages, right? So again, you're losing a lot when you do the translation. And so in my view, benchmarking is very contentious today, and just doing benchmarking is not enough. If somebody is telling you that their model is really good, only on the basis of some numbers on some benchmark, especially if it's a very popular benchmark, then I don't think you should believe them, because that's not enough information to say whether a model is better or not, right? You need something else. So here are some more examples of contamination. We tried to estimate for our mega work how many of those data sets that we used were actually likely to be contaminated in GPT. And the red bars are basically the ones that we think, we did different techniques to try and estimate contamination. And it seems like most of these data sets have already been seen. And so it's sort of like, cheating on the test if it has already seen the data set. There are all sorts of ways, as I said, to estimate whether something is contaminated or not. But those don't work very well, especially when you look at multilingual settings and so on, right? So, to summarize the benchmarking part, we found that, we are at a point where these frontier models do well on languages that are written in Latin scripts, but the smaller models are still far behind, and this has direct implications if somebody is trying to integrate them into an application, right? Your multilingual smaller models are not going to do as well as the larger models, and so you have to contend with higher costs, less efficiency, et cetera. But most importantly, today, as it stands, contamination really destroys the integrity of benchmarking, and so only benchmark results should not be taken as truth, right? It has to be supplemented with one of the other kinds of evaluation that I mentioned in order for it to be believable. So I'm going to switch now to the other kind of evaluation that we've been doing. So since the beginning of the year, we took up the challenge of evaluating the Indic models. And why is this important? Because we have these many or more Indic models today, right? So you'll be hearing, I think, in the next session from many of the builders of these models, but pretty much every day we have a new Indic model coming up. Many of them are fine-tuned versions of open source models like Llama, Mistral, Gemma, et cetera. Some of them are pre-trained from scratch, et cetera, right? Plus, there are also a whole bunch of other models that can also work for Indian languages, right? So we end up with a situation where we have around 30, 40 models. Which one do you pick for your application? Or you're a model builder. How do you know that your new model is better than all of these other models, right? So yes, we can do benchmarking, but benchmarking has so many issues that we decided not to go with the benchmarking route for this, right? So what else can we do, right? What are the other options that we have? So we actually decided to do human evaluation as well as LLM-based evaluation, and that's what I'm going to talk about for the next 5-10 minutes. So when it comes to human evaluation for Indic languages, right, we need people who actually speak all of these different languages in order to do the evaluation, right? And fortunately for us, we have a spin-off from our lab called Karya, which is an ethical data company. They were on the cover of Time magazine recently, which actually employs rural Indians all over India. And they really have people on the ground to do various AI-based tasks. And this year, their mandate is to do more GenAI kind of tasks. So we thought this is the perfect opportunity. Let's use our great relationship with Karya in order to do very large-scale human evaluation. And today, we've finished 50,000 human evaluations with the Karya workers. And this is a great source of income also for the Karya workers. And they are getting to decide which of these models are actually good in their own languages. Right? This is challenging, of course, because these Karya workers have not done this kind of task before. They need training. We cannot really go into the very rural parts yet, because they are not exposed enough to the technology. But we're trying, and we hope to scale. Right? So as I mentioned, Pariksha, which is the effort that I'm going to talk about, is basically a combination of human evaluation and LLM-based evaluation. So this is the kind of interface that the Karya workers see. This is a task that they have in Kannada. They do these tasks on the smartphone. So we need to design the tasks in a way that they can actually do the evaluation on the smartphone. And these are the kinds of Karya workers, they do this in their free time, etc. This is the first time this kind of population is actually being used for evaluation. Right? And what is really special, I think, in my view about this is that Pariksha becomes a research platform. Why is that? So I talked about LLM-based evaluation, LLM itself becoming an evaluator, etc. Our research over the last 1 year has shown that LLMs are reasonable evaluators in English. They still have some biases, like they have position bias and so on. But when it comes to the multilingual setting, things are a lot more shaky. It's not clear whether these LLM-based evaluators are actually, whether they're reliable or not as evaluators in the multilingual setting. We've tested on quite a few languages, and we see that for some languages, they do a reasonable job. For other languages, some kinds of evaluation, they actually give you complete junk. So how can we use LLM evaluators and make them reliable? Well, one way, and that is the way that we're doing, is by getting the same thing evaluated by a human and an LLM, and then comparing how well they agree, right? And if the LLM agrees with the human, and we actually get these things done by 3 different humans, each data point, then, and if it does that consistently for a language, for a kind of task, then we can be pretty confident about that. And then we can use that LLM evaluator to scale the evaluations, right? However, if we find that the LLM evaluator is not doing a good job at all, right, on a particular language, and we found actually for some languages it doesn't do well, then we disregard the LLM-based evaluator for that, and we only do human evaluations, right? So we can decide whether something should go to an LLM evaluator or stay with only a human. Also, what we can do is we can use the human evaluations that we have collected. As I said, we've already done 50K of them. We can use those in order to improve the LLM evaluator as well, right? And so this becomes a cycle where you use the human evaluations to improve the LLM evaluator and so on, right? So you get a better and better LLM evaluator, and you keep getting human evaluations as well. You keep an eye on the LLM evaluator, make sure it doesn't drift too much. So that's the idea of this platform. And there are tons of research questions that we've already started working on based on this. So as I mentioned, what we do is we get the same evaluation done by both humans and LLMs. I won't go into the details of the evaluation, but it's basically like an LMSys chatbot arena kind of setup, where the humans are shown outputs from 2 different models. They're shown a question and answers from 2 different models, and then they have to pick which model is better, which answer is better, basically. A is better, B is better, or tie. And the same task is given to the LLM evaluator as well. We've also started another kind of evaluation where a human has to rate an answer on some metrics, like whether it hallucinated, whether it whether the grammaticality and the linguistic acceptability is correct or not, etc. That also we have started recently, but most of our evaluations have been this comparative kind of thing, and the Karya workers, the feedback we've got from them is that they are able to do this task. So they are able to see the question in their own native language, of course, everything, and then the 2 answers, and then pick which one is better. Right? And so we did a whole bunch of things for quality control. So we want to do quality control both of the human evaluation as well as the LLM evaluation, right? So for the human evaluation, as I mentioned, we do 3 people do the same data point. So we have inter-annotator agreement. We can see how much the humans are agreeing, and so we can use that to check the quality of the evaluation. We also do this option flipping kind of thing. So sometimes we mix A and B and then see if they're being consistent or not. We find a lot of consistency actually both. So here the blue bar is the humans and the red bar is GPT-4 as an evaluator. And both humans and GPT are pretty consistent when it comes to options. So A and B being flipped. Now the really interesting thing is how well do the humans and the LLMs agree, right? And so we have some metrics to compute this. But here, higher is better, and you can see that for some languages, right? So what you're seeing basically is you want to see whether the blue bar and the orange bar are similar or not, or high enough or not, right? And so you see that the agreement for Marathi, for example, is not very high. The agreement for Punjabi is not very high, right? This means that the LLM and the humans are differing more for Punjabi and for Marathi. For Kannada, actually, the agreement is quite high, right? And you'll see that in the leaderboards also. So let me show you some leaderboards from the Pariksha effort. So on the first leaderboard you see is the Kannada one. And you can see the human leaderboard. So this is the leaderboard that we created based on only the human evaluations. And then next to it, you can see the leaderboard that is created only based on the LLM evaluations, right? So you see for both of them, Llama 3 is on top, right? And you see that there is some difference in the ordering of the next 3, 4. So Aryabhatta actually is second and third by humans think it is second and third, whereas the LLM puts it a little lower. LLM puts GPT-4 a little higher. GPT-4 itself is the judge, and this is a known bias that these models as judges prefer their own output over other models. So you can see that clearly in this leaderboard. In the middle of these leaderboards, you see various LLMs that have been fine-tuned versions of basically the open source ones, like Llama and Mistral and so on, right? So those are somewhere in the middle. So they're still not on top. So they're not yet beating these huge, like Llama 3, 70 billion, and GPT-4 kind of things. However, the Aryabhatta models are really doing well in Kannada. And you can see that this is fairly consistent, the two leaderboards, by the humans and the LLMs, which sort of validates both the human evaluation as well as the LLM evaluation. For Hindi, you can see the list again. So here as well, you have some interchange of the leaderboard, but overall the trends are pretty good. So Samvad LLM does very well. So it's on first and second place for humans and LLMs. Llama 3 is also doing pretty well. GPT-4 again is a little higher for the LLM-based evaluation because of the known bias. If you see the bottom of both of these leaderboards, you see that these Mistral, Llama, etc. are there at the bottom. These are the smaller versions and the non-fine-tuned versions. So it means that by fine-tuning these models, right, you are getting something. Like, you are actually making the model better on that language, right, according to these evaluations. So I'll flash one last image, and this is going to be hard to see. So I'll try to take you through this. So we've actually finished making these leaderboards for 10 Indian languages, and we've covered 30 models in all. And as I said, this is what the 50K human evaluations were for, and we also did equivalent LLM evaluations as well. So the left leaderboard is the human one. Sorry, the left image is the human, and the right image is the LLM one. And I won't go into the details of this, but you can see that the pink dot is Llama 3. So if you see like the pink reddish dot, right, that is Llama 3, and you can see that that is actually consistently pretty good for all the Indian languages. And if you see the red cross, right, that is GPT-4. That is also reasonably good. And the green dot also, so green dot is Gemini Pro. It's available for some languages, not all. That's why it's not there in all of them. That is also doing very well. And if you look at this, we're going to put this on our tech report in a couple of days, but if you look at this more closely, you can really see the trends very clearly about which languages are doing well, which models are doing well in general across these 10 Indian languages and which ones aren't. Right? So I think this actually shows that this kind of evaluation actually gives you a picture about what humans really think about these models, right? And which models are actually being rated high. And given that we have pretty good quality of evaluation, right, from the humans, we can be fairly confident about these results. The only drawback here is that the number of prompts and questions that we use are still limited because of the setup that we use, the kind of battle setup that we use for the chatbot arena kind of setup, but we are working on increasing that also, and we are also working on doing domain-specific evaluations like healthcare and medical, education, agriculture, etc. So the questions will be in those domains and will be posed not to Karya workers, but to domain experts from those fields. So I'm going to end here and say that, over the last few years, evaluation as a means to understanding the models, right? This evaluation that we do is not just to create leaderboards. It is to gather insights that will ultimately help us improve these models. The tokenizer example is a good one. So we figured out that, Latin script languages, non-Latin script languages, tokenization, et cetera, early last year. And we know that so many Indic developers and also GPT-4o, right, most recently, has actually acted on those things and made the tokenizer much better, right? So those kinds of insights you can get by doing good, careful evaluation, and that's our motivation even behind Pariksha. It's not just to create leaderboards, but to actually tell the community what are the issues that are there in the models, what are the challenges that are still remaining, what can we all fix together as a field. And for Pariksha specifically, we are going to be releasing all the evaluation artifacts, all the data, all the evaluations from humans as well as LLMs, so that the community can actually benefit from them, both by looking at the data as well as training their models on the data. One of the things that I didn't talk about much is, I was mainly talking about evaluating these foundation models, but evaluating systems is also an important area of research. And similar techniques can be used for evaluating end-to-end systems, although you will need many more kinds of evaluations in those as well. Automated evaluation has become very popular, the LLM-based evaluation that I said. People are using it quite indiscriminately these days. And so we really need to make sure that those are actually aligning with either the human preferences, if that's what you're optimizing for, or any other online metric that you have, like click rate or whatever, right? It has to align with that in order to be useful, so that, and especially in these low data scenarios, like low resource languages, if you use them without checking whether they actually make sense, you may be getting wrong insights, right? Which will further make the system worse for those languages. Multilingual evaluation is still very challenging. So with Mega and so on, we got some idea about how it works for these 70-ish languages, but that's still not enough. There are many languages that are still not covered, and even in those 70, there are many that have very little coverage, right? So there's urgent need to scale this multilingual evaluation. There are so many models coming up, right? We really need to have strong evaluation suites in order to tell whether these models are better than each other, better than the previous generation of models, et cetera. And as I mentioned, I showed you 4 different ways of evaluating, and I don't think any one of them is foolproof or can scale. So we really need a combination of approaches when we are doing evaluation. So I'll end there, and I think we're going to take questions next. Thank you.
Hello. Thank you, Dr. Sunayana. That really, you covered a full spectrum, I must say, from evaluation benchmarks, your experience, Indic languages, what are the positive, negatives, where are the challenges. I think it was truly interesting. One of the questions, and you did talk about it, is you said, okay, there is a combination approach. You looked at both human and LLM, and you spoke about contamination. So isn't that LLM Evaluator itself has a bias and a contamination in the first place to influence your results?
Right. So when we talk about contamination, we're talking about benchmarks being contaminated into the data. But the LLM Evaluator typically does not have any reliance on the benchmark. So it's being asked a very open-ended kind of question, especially the reference-free one. So for the ones that still need a reference, that is true, that if it has already seen the data, it may be biased. But the typical LLM-based reference-free evaluator is, you give a chat to it, and then you ask it, did this chat go well, right? How was the engagement in this chat, or did the task get completed or not, right? So for that, it doesn't matter whether it has seen benchmarks, because you're giving it something completely new to evaluate.
So just to engage with the audience, let me just, by show of hands, can we see how many of you have either trained or worked on open source models or trying to work on LLMs now in terms of understanding how they perform? And any show of hands on Indic languages or language tuning? Okay, so I think you did touch upon a lot of Indic languages and open in terms of if somebody has to start from picking up and working on. I mean, there's supergiant models which are getting tuned and performing better, like we saw in your results, and also that pure Indic languages which could be performing even better in some undersourced situations. What is your recommendation if somebody has to start, and are those Indic language models existing right now?
That's a great question. So I think it depends on what you're trying to achieve. So if you're trying to build for a particular use case, then I would say, to really focus on getting data, an evaluation pipeline, etc., for that particular use case. If it is more general, like you want to improve LLMs for, say, a particular language, right? You want to make a really great Kannada LLM, right? How do you do that? So for that, I think there are already a lot of techniques that people have been using. Some of the larger models are already doing them. But again, finding good data in order to fine-tune these models if needed, right? Finding good sources of data that mirror the kind of applications that that model is likely to be used in. And also making sure that the evaluation is good, right? I mean, you need to tell whether whatever changes you're making to that model are only going to be better for a particular benchmark, or whether generally that model is going to get better at understanding, producing Kannada or not, right? That is a hard problem, I think. I mean, I think human evaluation is a great step towards that. It may not scale very well. That is a problem. But I think, getting a few native speakers to actually interact with those systems is very useful.
Just come to IVK now. Just want to ask IVK, you have a vast experience in BFSI, travel, retail domains. Where do you see the real use of Indic language LLMs and even code-switched language LLMs, right, in our context of bilingual and trilingual?
Yeah, so I speak from a startup perspective, so you should take it with a pinch of salt that that's not essentially a corporate view, but in a startup, there are two things we don't have, right? One is time, other is money. So our choices in selecting what model or what technique we use is actually used, driven by those other compulsions. However, if I pick the most popular use case for conversational API, for example, and I would say at one time, maybe a couple of years ago, it is still a problem when you have mixed language chats, right? I don't say it's mixed language, maybe you borrow a few words from the other language. It is primarily in English, maybe with a few words from Tamil, Telugu, Kannada, Hindi, right? So if you're booking a cab, maybe it cannot follow. But I think nowadays, I think that is perhaps a solved problem. So that's an easier one, so I would say low-hanging fruit, yeah, that's perhaps a solved problem, yeah? Because they are high on task context, right? But the same example if I give to a recommender system, where you are using a chat as a front end, but have to recommend a wealth product. Now, it is not that the LLM cannot understand what you're saying, but the problem lies elsewhere. So it is viewed as an LLM problem that the answer seems to be wrong or not relevant. But the problem lies not in the LLM or interpretation, the problem lies in the backend in matching the product ontology, which is a behavioral finance issue, rather than a conversational API issue. So if I say that I trek in Himalayas, I do scuba diving, that doesn't mean that I will invest in a hedge fund. So mapping it to a transfer learning into a portfolio of investments do not come from the risk you take in your other activities, which is not exactly an LLM problem. That's a problem elsewhere. So I would say it is, unfortunately, most people say, oh, the bot got it wrong, right? But maybe it is not the front-end problem, yeah? The other question I found in travel, for example, which is also high context because you know where you're going, etc. But if I give you a slightly different example of named entity resolution, which is another case we normally try to process language or the multi-language inputs. Now, while it is true in India that most of the names are actually written in English, while they may come from a local culture, right? So if I write a Balaji sweet meat stall, it is written in English, but they don't sell any meat. It's a very classical cultural element, right? So on merchant analysis, where we have names like this, what we find is, this is of course in Indian context, it's maybe much easier for me to use a few people to solve it because the record database is not that big. How many merchants will be there? 10,000 for a bank? I will do it with people. I don't need to run a famous LLM to do it. However, if it is cross-border, suppose I have to sell in 15 countries, and I have 15,000 merchants to do, and one of them is Arabic, oh, then I'm going to use something like that. So I would say the case is based on, it is not completely mixed language in strict sense, but with borrowed words, yes, But as we often do in India, we now equate AI with LLMs, right? We used to equate AI with ML. Now, all AI is not ML and LLMs. So I think this is one of the issues we have in portraying that it is a problem with the bot. It can mean anything, right? It may be a classification problem or a heuristic problem, but you say you blame the bot or blame the LLM. So I would say maybe with those things, yeah.
Okay. Are you really using evaluation models in these contexts, or it's like drive as you go or test
So
as
that's
you
why I
learn
said,
and use?
when I was in corporate, I will do a theoretical evaluation. Of course, I do look at leaderboards. I'm not saying I will not look at them. But we do look at it. But in general, the approach is, even if I'm an ML engineer, I will just see what works for my context. And most of us are in a specific context, in finance, in travel, in manufacturing. So we apply it in that domain. I'm not solving a horizontal problem. So I would say, yeah, if it works for me, I'll do it, right? And in India, because I can get few people to do it in 2 weeks, I may not run a big system, yeah? But in some cases, I do use it.
No, so then I'll come back to Sunayanana here. So we, in our context, are doing AI-based recommendations for learning and other use cases for Salesforce enablement. Now here the challenge is, how do we prove, I mean, it works. Like he said, as we put it, it's out there, it's working. The SMEs are saying it's great, but how do we prove to a larger stakeholder audience that this is meeting the benchmark? So this is getting better as we go. It's getting more accurate, or AI is kicked in as we keep pushing more recommendations. How do we actually see and learn? Or what is the kind of evaluation that will drive us there?
That's a very hard problem. I think that is, a lot of people are facing, including us. So I think the best thing is, since you're already attached to a use case, right? You can do that use case based evaluation. So if you have users, nothing like it, right? Thumbs up, thumbs down, or something, or even offline metrics that you compute, right? Whether they kept the suggestion, whether they looked at the suggestion or not, whether they rejected, how many times they came back to your application, whether they stuck to it or whether they abandoned it after one day. Those are all really great signals, I think. They're usually sparse signals, that's the problem. So you may get a few signals here and there, or only a few users may actually give you the DSAT, like the reason why they did not like the answer or do the thumbs up, thumbs down. That's the problem with that. But that is a very good signal, I think, to tell. And then, of course, when you ship something, you have multiple versions of the product, usually some model in this, for this particular audience, and something you split it, you do A/B tests and things like that. Those can give you some sparse signals. So the LLM-based evaluation is what really shines here, right? Because the LLM can go and look at these complex scenarios and can tell you whether it did a good job or not in that complex scenario. So you can make the LLM behave like a user, basically, and simulate a lot of different conversations, and then have another LLM go and evaluate or rate those interactions, right? That's the thing which is very powerful, and it seems to do very well in some scenarios, but there are some places where it is biased. So those blind spots need to be caught. And if you can, then I think that's a very powerful way of doing this kind of complex evaluations that these metrics and benchmarks can't always do.
Probably scalable, but cost factor is
there, yes. And here again, the large models are the ones that are shown to be good evaluators. The small ones can't do good evaluation.
A challenge. Okay. So I think question to both of you. I think there are more students here, and in terms of what we see, most of the companies at least are not really going into algorithm. They're picking one of the open source or available models and fine-tuning it to their use cases. If that is so, what is the real hiring skill, especially with startups? I mean, they may not have the luxury to go in for a data scientist, ML ops, DevOps, and so many skills. What is your recommendation for both entrepreneurs for hiring or for students to pick up as skills in this space?
Okay, I'll just add one more point to the previous conversation. In case of solutions where you offer, say, an option to buy something in e-commerce, like a restaurant recommendation or a fashion recommendation, you're not asked to prove rigorously or theoretically that it is fair, etc., because then the conversion rate falls, so the marketing manager will say, I'm not getting enough conversion. So you might get upset with it, but you're not going to get into trouble. But there are other products where, for example, I decline a loan. Then you have a problem, because I have to explain my fairness. So I would say that in certain cases, you do need a formal evaluation to show that I am fair, I'm transparent. In many cases, you don't have to, but in some cases, it is mandated. So I think there is, even in health, for example, medical, right? So I would say that even if I'm a startup, I mean, there are some areas where I need to have a certain proof. Now, to answer the question you asked on the profile, see, I have played with these different profiles in the last 10 or 12 years of running this startup. My view is, I would, so this is the original debate of whether I need a mathematician, whether I need a computer science person who can understand the model and evaluate, or do I need a developer who can actually code? Now, in LLMs in specific, since most of us run inference engines, we are not doing any training or any horizontal models, right? Just run an inference engine. So I would say the person who's closer to running it, whether it is MLOps developer is what I prefer, but I need at least one person who knows a little bit theoretical foundation. I don't need a pure mathematician, okay? So in general, I think we have also shifted in our profiles that, I mean, I had a data science head who was a double PhD in mathematics, but that's not a problem I actually solve, right? I solve a slightly different problem, right? So it is how I deploy, how I execute more efficiently is more important than how theoretically it is a better solution or elegant solution. So that's what I would say.
Yeah. I completely agree. I think, some of the skills that I look for when I usually hire people right out of college. We have this research fellow role. We have a lot of interns as well. So, one of the things is the ability to think end to end through a problem, like to figure out, first of all, whether that problem is important or not. This is a difficult skill, that comes with practice, but at least to know whether the kind of problem that they're thinking about is relevant today or not. And then how one would go about potentially solving it, not the particular technique, but what is the sort of like the meta thinking behind it, how one would evaluate whether whatever they're proposing is actually good, whether they're able to do basic experiment design, how to compare different systems, keeping factors constant, only the thing that they're changing should change, those kinds of things, basic things. These, of course, come with experience, but basic things. And, most importantly, I think not getting carried away by hype and sort of only chasing whatever is cool right now, because that's going to change very quickly, right? And having the sort of the skills to learn quickly on the go, on the job. So I think that, having that kind of a sort of a flexibility towards what they're willing to work on, and also fundamentals are super important, of course, and the ability to think through a problem end to end and, be able to reasonably execute it reasonably. Like you can always learn, a new package or a new, language or something on the job, but that the way somebody is able to think, I think that is really crucial today. And another skill, I think, that is becoming very relevant, especially among the students that I interact with a lot, is just the ability to absorb a lot of information that is coming today, but not get affected overly affected by it. Because, a lot of times, like my own research fellows come to me and say, yesterday I thought of this problem and wanted to solve it. I found a solution. Today morning I saw on archive there is already a paper on it, right? And so this can be really demoralizing, but having that sort of resilience and knowing that in the end things will work out, and that maturity, I think that is also very important, because it is a hard time right now with the pace of innovation today. So I think that's really important.
Okay, I think one last question from my side, and we'll throw it open to everyone. So in terms of responsible and ethical AI, where do you see the evaluation models or frameworks moving, and even from your perspective in the industry, regulators, do you see, what's the trend in terms of evaluation benchmarking to be more responsible and use ethical AI?
So I think there have been quite a few benchmarks that have been proposed for toxicity and bias and things like that, right? Mainly in English. There are some multilingual versions also coming out. But again, these have the same problems of benchmarks, that is, many of them may be contaminated and so on. And also, many of them are very narrow in their view, especially when it comes to culture. As IVK was mentioning, right, different cultures have different nuances. And a lot of these RAI data sets just don't cover other cultures or other viewpoints, right? And we've seen, multiple controversies in the last few months about these things, where there may be a whole section of people who don't agree with, whatever is termed as like the Western viewpoint on a particular thing, right? And are we evaluating for those things or not? Or are we assuming that everything is going to come from one school of thought only, right? So those are the kinds of things that are really missing, I think, today. Again, LLM-based evaluators have been used even in the responsible AI setting. This again, may not be ideal because the LLM evaluator, LLM has been trained on predominantly one kind of cultural or language data. So I think there's a lot that can be done for doing better benchmarking or automated evaluation. And also somehow trying to involve more humans from across the world in doing responsible AI, because that's the only way we will get all that cultural information into these evaluations, right?
Your thoughts, Adiki?
Yeah, I think I've come across a few scenarios where, you're asked to explain. So typically, if you are in the digital marketing side, which involves commerce at the end of the day, so in many cases, you are asked to give something. For example, you have a premium on novelty. That you are running a system because you can come up with recommendations which are more interesting than what they're already doing, right? There is also a relevance, right? So you need to, it's an orthogonal problem of novelty and relevance, right? In many cases, you can get away with novelty because saying that it's an interesting suggestion, so you can act or not act upon. But in some countries, this is where the regulation comes, and this is where the base models have an impact. In some countries, I cannot recommend certain things. Certain product categories are banned. You will go to jail if you do that. Now, I have no idea what the base data set and trained model was. Right. So whether there is a data drift, whether there is a model drift, I have no idea. So you need to give an assurance that you will not give such recommendations or you will not say such things, right? There can be a gag order on you, for example. Right. It is not very easy to solve the problem, so I have to have somebody to actually check it. Right. So which is where I think, as you said, it is a, what you call a wicked problem, as they call it in mathematics and computer science, right?
Okay, with that, we'll open for questions from audience. Any? I know it's a post-lunch session, so but it could put you to sleep, but anyone has any thoughts, any opinions to share from your examples, whoever is fine-tuning and working on Indic LLMs, anything? You have any thoughts to?
I have one question for Sunayanana. Now, this is a student question, but it's a serious question, actually. So it's actually a thought experiment. So let's assume that let's have language 1, which is, say, English. And let's say there is language 2, which matches the number of alphabets or the number of characters in the script, right? So I type a 5,000-word essay on my laptop using the first one, language 1, say English. Now I put a different keyboard, since it's all the same, 1:1 matching, the position of the key is the same, except that the character in that language is different.
Right.
And I type another 5,000 words essay. Now, if I use an LLM to do a summarization, for the second one, do I need to retrain? Or will it work? And is there a change? Or do I need to do from fundamentals that I have to start doing word embeddings and stuff like that? So how do I solve that problem?
Yeah, I think it will not work very well because the tokenizer itself is trained on the English vocabulary, right? So that will know how to break up English words into subwords that are meaningful. And so those subwords will not be meaningful in your new language, right? And so I don't think that will work very well. However, if you actually instruct it, and this is just a guess, right? If you actually instruct a very powerful model that this is what you have done, right? You have actually done this. It's basically like a cipher kind of thing, right, that you have done. If you actually tell it, then it may be able to figure out the mapping because it knows what the frequent words are in English, right? And so it knows like the frequency of characters and things like that. And it could do that mapping and actually, so if you do like chain of thought or something, maybe it will actually figure it out. But just, like a straight prompt, I don't think it will be able to do that. Yeah.
So I think from your analysis of linguistic and presence, and we have seen that so many are undersourced in itself. Have we widened the digital divide overall? Where do you see in terms of inclusion of a lot of cultures and languages? Where is this leading the evaluations?
Yeah, that is a very good question, and that is the question we were trying to answer with the mega and evaluation work. It's not clear whether we have, widened the digital divide or not, because these models are capable of doing a lot of things, even in other languages. But what is sort of clear is that it's not so easy to steer them to a new language, right? Earlier in the smaller models, especially if you had a specific domain, right? Then you just fine-tuned on that task or that language and it would work well, right? These days, because of the unpredictability of these systems, it's not clear whether doing that is enough or whether, some other issues come up. Also with fine-tuning, right? We find that there is a lot of forgetting that happens when you fine-tune on a particular language. So if you have if you have something like, which is a strong English model and then you fine-tune only on multilingual data, usually the English performance tanks, right? Which we can't afford if we are in, like, especially in a society like India where English is used a lot, right? So that is an issue. So I think the unpredictability is what is, a little difficult to deal with. And so that answer is, that question is unknown right now.
I had a question. A lot of these benchmarks and tests, and you talked about contamination, and I would say cheating, quota-style cheating. You know the questions beforehand and all that. What is the process by which you have task-based tests, real world, like investment or something, which are not available on the internet for other models to be trained on? Or there are ways to test that the model has not seen those tests? Yeah. Because in some of the people I have known, GPT, etc., don't do more than 16% pass on these tasks. Yeah. And that is a real benchmark for a business case. Absolutely. So any questions or any answers on that?
That's a fantastic question and really timely also. So one way is, of course, that all companies have their own internal benchmarks that they don't release, right? And so they do test on those internal benchmarks, and those are guaranteed not to be contaminated because they never release them to the outside world. Although, I mean, people have found that, sometimes contamination can be indirect as well, right? When you're interacting with the model also, you are submitting information to the model, right? They may be doing some prompt tuning or something, even when you're doing evaluation. The real solution to this is something that my colleagues at MSR India have been working on, the crypto team actually, it's called private benchmarking, where using cryptographic protocols, you basically have cryptographic guarantees that even though you're doing that evaluation, the data set is not seen by the model. And you can do it either with secure hardware or with this actual multi-party computation protocols, where you can guarantee this. So if you have a new data set, you keep it private and only evaluate using these kinds of secure protocols. That will guarantee that that is not going to be seen by models. So that is actually a new platform that they're building. And if anybody wants to donate their benchmarks to that platform, right, to make private benchmarks, please contact me and I will get you in touch with them. But yeah, that is something that we are looking at in the future. Because as much as, I complained about benchmarking, it is still very replicable, it is still very fast, it is, relatively cheap, etc., and that is why it is so popular.
Okay, great. That's an interesting closing note, and you can reach out to her if you're interested to contribute there. Thank you so much, Dr. Sunayanana and Vijay Kumar Ivaturi. It was a great session with you.
Thank you so much.
Thanks a lot.